It was about 6 months ago when I came across today's spectacular feature on Google Earth. I was looking around for interesting geologic formations in the desert when I came across this. An isolated slab of stone that looked like it had been diced up by a knife. Perfectly straight lines all intersecting at near right angles, forming a strange natural grid pattern. All the nearby sandstone is relatively smooth, and it's only this small area of rock that was fractured into the geometric pattern. Of course, I had to go check this site out in person, not only to appreciate and document its strange beauty, but also to try and figure out how it even formed. What I found at the top of this rock formation ended up being much more fascinating than I ever could have expected. Hello, and welcome back to the desert again. It's another cold desert morning, and we have a pretty quick but hopefully very exciting adventure planned for today. I realize I never say my name in my videos, but my name is Landon. That's Martha. I say Martha's name all the time, but my name is Landon. A lot of people just call me Topo in emails and stuff. I realize I should probably say my name more. Anyway, yeah, we're just a couple miles from that super rare geologic feature that I found on Google Earth. And we're just gonna go take a look at it today, hopefully climb to the very top of it, and it's gonna be really exciting. So let's get going. So the rock feature we want to visit today is off trail, and whenever you're going off trail in the desert, you want to try to stick to washes like we're in now, and then try to get directly up onto bare rock, because all the desert soil is very fragile and stepping on it pretty much destroys it for a while. So it's best to just walk in these washes and rock that don't have any soil. So the one problem with walking in washes is occasionally these big deep spots will collect a lot of water and you just get a huge pool. If we were in a slot canyon, this would be a big problem because there'd be no way to get around it. But for us, we can easily just scramble around the sides. Now that we're up on the bare sandstone, you still get pools, but they're in solid rock this time. And I can't even tell where the bottom of this one is. It might be really deep. So when that thing empties out, it's just a huge pit in the ground. Okay, there it is. And right now we can only really tell the east-west parallel fault lines, but once we get up there, we'll be able to see the north-south ones as well. And we'll see that all of those are cubes, not just rows like we're seeing now. Okay, the faulting is getting pretty evident now on this Navajo sandstone. Right here, you can see an east-west fault intersecting with a north-south fault there. And it continues on that way. And it seems like the east-west ones are eroding pretty dramatically into these slots. Okay, I was definitely not expecting to see anything like this up here, but here it is. There's what seems to be an old granary here. This hole actually goes so far back, really deep in there. I don't know if you can see very well. There's nothing left in there. But yeah, that's an ancestral Puebloan granary that they used to probably store food. Because here we have another one of these east-west faults, and that alcove just kind of formed in the wall, and they took advantage of it. That is really cool. I knew there was stuff in this area, but I just didn't expect to see anything up here because I didn't think there was any alcoves for them to use. But there's a little one. Also, just to highlight a natural feature that's quite insane right next to this ruin. This juniper tree is growing out of solid stone, just wedged in this crack. And that's just insanely impressive. I mean, no soil, just rock, and it's thriving. Okay, you can really see the bumps of the square blocks now, and we're almost to the top where we'll get a great view of them from above. Here's another great example. There's that fault. Here's this one. You noticed there seems to be plants at almost every intersection. There's that fault. There's this one. I'm thinking it's because the water flows down the faults. So the plants just take advantage and grow at every intersection point. We have an arch up ahead and a stone tower. That is weird. It's getting pretty steep now. Wow. This thing is a balanced rock over there. I'm gonna try to get up here though. Here is a giant cube of stone that kind of looks like a loaf of bread, to be honest. But you can see the kind of right angle, and I don't know, this section must have just been harder than the surrounding rock because it survived and everything around it didn't. Natural cube. Okay, I'm almost at the top. Martha's just behind me, but the erosion is getting stronger up at the top, so it's pretty steep and pretty cliffy at these fault lines. I'm standing at a junction right now. You can see this fault line is making that wall, and then this fault line is kind of making the divide between these blocks and the loaf of bread here. Yeah, I'm not sure what this was. Maybe like a watch point. Oh wow, there's another wall right there. I didn't even notice that earlier. Oh, that's really weird. I wasn't expecting to see anything up here. Archeological. Yeah, I don't know. Maybe a watch point. Could be a hunting blind, but I don't know why you'd be hunting up here. Because it's only one side, you know. This back side is open. Maybe wind shelter. But I just don't know. Next to Martha is kind of a eroded one. That one's really falling apart. So maybe they're just all over the place. Give me your theories on what this was for. I legitimately do not know. We now just need to climb this thing and we'll be at the top of this whole area. This is the tallest thing for quite a few miles, I think, in every direction. There's a nice pothole up at the top here. Yeah, that's a pretty big cliff there. Wow. Another nice pothole. So as I mentioned earlier, all of this sandstone here is Navajo sandstone. And you may be wondering how I know, and that's all thanks to Backseat Geologist. Backseat Geologist is this really cool app. Basically, it takes your average mapping tool like Google Maps or Apple Maps, and it displays geologic maps on top of that. So you can see what geologic layers you're standing on. And you can read about them in the app, or it'll just read about the geology to you. And 2 new features have just been dropped for the app. It's now on Android, and there's a new very cool tool called Overlook Mode, where you can actually point your phone at any view you're looking at and it will tell you about the geology across that view and not just where you're standing. It's an absolutely amazing app, and I really do use it all the time for my videos to learn more about the geology. So if you want to learn more about geology while you're hiking or driving or whatever, just download Backseat Geologist. Now that we're at the top with a great view, let's talk about the geology. To be honest, I could not find any specific information on this exact formation, so I'm going to give you guys my best theory on what this is. To me, this looks like joint faulting, specifically 2 sets of joint faulting. Joint faulting occurs when a slab of rock is placed under stress that results in it undergoing brittle fracture to compensate that stress. The stress can come from any number of things, like the rock being stretched, bent, or thermal contraction. The brittle fracture then creates many parallel cracks or faults in the rock, which are called a joint set. These are quite common around the world, as rocks are often undergoing stressors. In the American Southwest alone, there are thousands of examples of it, and they often form some very cool formations, like the Fins of Arches National Park. However, what has occurred at this site is another joint set, fracturing the rock perpendicular to the original joint set. This then becomes a joint system, as we have two sets of parallel joints dicing up the rock. The most famous example of this is in the Needles district of Canyonlands National Park, where this joint set has resulted in thousands of cubic and rectangular blocks eroding into pointy spires that were aptly named the Needles, as well as some deep slot canyons along a lot of these fractures. Guess what the most famous slot canyon in the Needles is called? Yep, that's right, it's called the Joint. Wonder where that name came from. In the case of the Needles, the first stressor that jointed the rock was the monument upwarp, which bent the rock and fractured it roughly east-west. The second stressor comes from the salt layer, deep below the sandstone, which is moving west. This is stretching out the rock and causing it to fracture roughly north-south. Now the real question is, what are the stressors on this slab of rock? Well, the north-south faults seem pretty easy. I think they came from being bent. This slab of stone sits on a monocline, which is essentially a giant S-shaped fold in the rock. The stress from this fold must have created the north and south faults. However, I am not really sure about the east-west ones. Maybe there was some sort of compression and bending at this spot in the fold, but honestly, I'm really not sure. Any geologists in the comments, please let me know your theories about the east-west faults. The main difference between this spot and the Needles is this joint set is in a much earlier erosional phase, where it has not yet had the time to form massive slot canyons or pointy spires. Instead, the fractures are just barely visible, and it's best enjoyed from above, where its incredible patterns can be seen quite well. Alright, let's go do some more exploring around here. I think some of the coolest things are yet to come. Trying to make my way down, but it's getting so cliffy over here. So I'm just gonna go through this little arch instead. Hanging on. Wow, I think I just spotted something really, really cool. I have to go over to it, which is going to take a minute, but you'll see in a sec. Okay, yeah, this isn't what I found, but I'm pretty sure this little valley I'm standing in here was lived in. There's no structures that I can see, but on the ground here is a piece of corrugated pottery. Make sure to always leave these. Just pick them up, look at them, and put them right back. That means that there were definitely people like spending time here, significant amounts of time. And that stuff was left there by the ancestral Puebloans. It's probably been sitting there for 1,000 years. Just mind-boggling. This is what I spotted from the cliff. I've never gotten to see those in person, but those are petroglyph bear prints, it looks like. Really, really cool. I knew that that was a thing that was carved once in a while. And then all of these, I think I've learned that these are sharpening scrapes, because I mean there's just markings like that all over this place here. Right here. Some of these might be graffiti. That's probably graffiti. But I think, oh, yeah, those are probably authentic. Yeah, you can tell because with this one here, it's white on the inside and orange everywhere else where the desert varnish has grown over this rock. But all of these are orange on the inside, which means they're really old. I also got these, lots of pecked dots. Don't know what those are supposed to be, but, and actually that may be some pictograph. remnant back there. And then there are Moki steps, or carved steps, all in this wall here. So, I don't know, maybe this was a storage place. I'm not really sure. There is kind of a cave here, so who knows. Okay, I just keep spotting stuff while I'm trying to find my way back. And there's another ring of rocks. Kind of weird. It doesn't look like very good construction. They're really just piled. So, no idea what's going on there, but again, very interesting. Definitely was not expecting to see that many archaeological sites today. It's kind of one of those things where I come out here for the geology. That's what I research beforehand, but I always hope to see stuff like that while I'm out here. And it's really just a chance. You never really know until you go out there and explore. I had no idea any of those ruins or petroglyphs were there. You might think that this is a cave, but it's actually an extremely low arch. Kind of interesting. And I'm talking low, like this thing is only a foot or two tall, but it's a huge cavern in here. So I think this is about as big as these cracks are currently, but over time, this weak layer where it's fracturing will continue to erode. Took a quick side quest to the Needles just to kind of see what we were talking about in terms of geology for this video, and I just found an amazing sign that goes right along with what I'm talking about. So they have this great diagram here of how the Needles formed. You first had those joint faults making these kind of square blocks, and then gradually those eroded away. And in the case of the rock formation I found on Google Earth, we're not yet to this stage where there's a bunch of needles. Instead, it's kind of at an earlier state, probably about this, where we can just see the fractures, plants are taking advantage of it, a couple of them are eroding away, but mostly it's only visible from above. And then eventually they will erode into a bunch of slot canyons, and then the tops will start to wither a little bit and become more like spires. Okay, I think I'm about to the end of the fractures here. Let me know if you like this one. I love coming out here and exploring in the desert. It's a great time. Thank you so much to Backseat Geologist and my Patreon members for making it possible for me to come out here. See ya.